In this lesson, you will translate and reflect images. A translation is sometimes called a slide. It's the movement of a figure from one position to another without turning it. For example, if you look right here at this green figure, it is slid to here, or slid to here, or slid in this direction. It looks the same as the original. It hasn't been turned at all. It's just a similar figure moved to another place without turning. In our first example, it says graph triangle JKL with vertices -3, 4, 1, 3, and -4, 1. Then graph the image of triangle JKL after translation 2 units right and 5 units down. Write the coordinates of its vertices. So let's start by first graphing triangle JKL. Remember, when plotting ordered pairs, the first number is your x value. It tells you where to move right or left. And then the second number is your y value, and it tells you if you're going to move up or down. So -3, 4 means I'm going to go to the left 3 and up 4. And I'm going to label it J. Now for K, it's 1, 3, so I'm going to go to the right 1 and up 3, and we're going to label that K. And then L is -4, 1. Means I'm going to go to the left 4 and up 1. Now we're going to go ahead and connect those points with line segments. So there's triangle JKL. Now we're going to graph it after a translation 2 units right and 5 down. Well, 2 units right just means we're going to take each one of these points and we're going to move it 2 to the right and 5 down. And when we plot this, I'm going to, instead of labeling it J, we're going to label it J prime. It's a little mark, kind of looks like an apostrophe. Now we're going to take K and we're going to move it 2 units to the right and 5 down, and we're going to label it K prime. And then L is also going to go 2 units to the right and 5 down. And label it L prime. Connect them with line segments. You should have a triangle that is congruent to the original, and it has just been moved 2 units to the right and 5 units down. Now the ordered pairs for J prime, it's -1, -1. K prime is 3, -2. And L prime is going to be -2, -4. Sometimes, instead of them writing it out in words saying 2 units right and 5 units down, they may use this notation to describe the translation as well. If it says x plus 2, that means it's going to be moved to the right 2 units. And if it says y minus 5, that means it's going to go down 5. So you can find the coordinates of the new image by either graphing it and then figuring out what each ordered pair is, or you can just take the originals right here, -3, 4, and you can add 2 to the x number to get -1, and we can take 5 away from the y and we get -1. Same thing with the others. But you should be familiar with both it written out in words and with this notation. Next thing we're going to do is we're going to reflect a figure over an axis. We're going to graph triangle PQR with vertices -3, 4, 4, 2, and -1, 1. Then graph the image after a reflection over the x-axis and write the coordinates of its vertices. So let's start out by graphing the triangle to start. -3, 4 means I'm going to go to the left 3 and up 4, and I'm going to label that P. And then for Q, I'm going to go to the right 4 and up 2, label it Q. And for R, we're going to go to the left 1 and up 1, label that R. Now we're going to go ahead and connect those with line segments. Now if we want to reflect that over the x-axis, remember the x-axis is this one right here. So I'm going to just make that a heavy line so you can see it. Now instead of having R being 1 unit above the x-axis, we're going to have R being 1 unit below the x-axis. That line's a little thick, so I'm going to take that out. Maybe I can use this. Maybe this will be a little bit better. There we go. So again, instead of R being 1 above, if I want to reflect it over the x-axis, it's going to be 1 unit below the x-axis. So we're going to label that R prime. And then Q, instead of being 2 above, it's going to move down 2 from the x-axis. And that's going to be Q prime. And then P, instead of being 4 above, it's going to be 4 below the x-axis. Label that P prime, connect those points. And you should have a triangle that's been reflected over the x-axis. You should be able to visualize folding on this blue line, and the two triangles would match up with each other. So now let's go ahead and write down our ordered pairs. P prime is at -3, -4. Q prime is at 4, -2. And R prime is at -1, -1. Now if you compare our original ordered pairs to our new ones, what do you notice? That's right. The y-coordinates became the opposite of what they were, and the x-coordinates stayed the same. Which makes sense because if you're flipping it over the x-axis, the y number is going to change. Instead of being positive, it's going to become negative, and instead of being negative, it's going to become positive. Now in our third example, this time we are going to reflect over the y-axis. The y-axis is this one right here. So I'm going to start out by plotting the quadrilateral ABCD. To plot A, we're going to go to the left 4 and up 1. Label it A. And then for B, we're going to go to the left 2 and up 3. Label it B. And then for C, we're going to stay right there and go down 3. Label that C. And then for D, -3, -2 is to the right 3 and down 2. Going to label that D. Now let's go ahead and connect those to make our quadrilateral. Now if we want to reflect this over the y-axis, C is actually going to stay right here since it is on the y-axis. So I'm going to say C is equal to C prime. They're in the same spot. Now D, instead of being 3 to the left, it's going to be 3 to the right. And we'll label that D prime. B, instead of being 2 to the left, it's going to be 2 to the right. And A, instead of being 4 to the left, it's going to be 4 to the right. Label that A prime. Connect them. And when you're finished, you should have a quadrilateral that is congruent to the first one, and it is reflected over the y-axis, meaning I could fold on the y-axis and the two quadrilaterals would match up. Let's go ahead and write down the coordinates. A prime is at 4, 1. B prime is at 2, 3. C prime is in the same position. It's at 0, negative 3. And then D prime is at 3, negative 2. Now if you compare these new ordered pairs to the old ones, what do you notice? When you reflect over the y-axis, the x value changes to the opposite, which again makes sense because if you're reflecting it on the y-axis, instead of going right, you're going to go left, or instead of left, you're going to go right, which means you're going to change the x number to the opposite. All right, the last thing we're going to do is reflect over the line y equals x. Well, the line y equals x is this line right here because the y-intercept is 0 and the slope is 1, so rise 1, run 1. It's this line that splits it perfectly down the center of those two quadrants. If you want to reflect over the line xy, what you're going to do is switch. You're going to take the x and the y and you're going to switch them. So if I wanted to reflect 3, 4 over the line yx, let's first plot 3, 4. So to the right 3 and up 4. Now if I want to reflect it over this line, I want to switch the x and y coordinates around. So it's going to be 4, 3. So that means I'm going to go to the right 4 and up 3. And if you notice, I could fold on this line right here and these 2 points would match up. The last thing we're going to reflect over is the line y equals negative x. If you want to flip over the line y equals negative x, you're going to switch your x and y around again, but you're also going to make them the opposite signs. So for example, if I want to reflect 2, 5, let's first plot 2, 5. That means to the right 2 and up 5. So now if I want to reflect it over the line y equals negative x, I'm going to switch them around and make them the opposite. So it's going to be negative 5, negative 2. So we're going to go to the left 5 and down 2. Now you should be able to visualize folding on this line, and these 2 points would match up.